A lot of the time I get this question about, women in high tech and how we bring more women into high tech. And at the end of the day, it's just positive experiences. If you're told, oh, wow, look, this works, you find that you're good at it, then you will continue doing it.
What exactly inspired you to go into software development?
Well, it was not an inspiring moment. It was probably a lazy moment. After coming to Israel from an English-speaking country, and the language is a little new. Math is in English. Computers are in English. English is in English, and you could actually get through high school, doing just a little bit of this and this, a little bit of that, and some math, some physics, some computer science, and that's what happened. And I think, like everything in life, if you're good at it and if you get positive reinforcements, you feel good. And if you feel good, then it's something you'll continue with. So a lot of the time I get this question about, women in high tech and how we bring more women into high tech. And at the end of the day, it's just positive experiences. If you're told, oh, wow, look, this works, you find that you're good at it, then you will continue doing it. So it started in high school. I found out that I was good at it. I continued at the university in California, UCLA, which there again, it was okay. I managed to pull through. University is a lot more difficult than high school. And then when I got back, I went to Bar-Ilan University, where every girl goes to get her MRS, because university does a lot of the work for you, right? So they have to pay their way to get to school, and once they're decently okay, and they have to be smart because they have to get in. So now you just have to find somebody cute. So it's actually quite great. And then after that, I went to work for a company called Sela, which they did a lot of consulting and courses. And that was perfect because I had kids. And it's really difficult to, at least back in the 90s, it wasn't like today where you could work from home, and high tech was a really demanding job. It wasn't like it is today. We worked crazy hours, and in order to not be there but stay up to date, I went into consulting. Hey, consultants coming at 8, you want a consultant, you better be there at 8, right? I mean, no, our developers only started at 11. Well, I'm going to be there at 8 and I'm going to leave at 2. Right. And you can pay for it. And again, if you're good, then there's demand, and then you can say, well, listen, I work from 8 till 2 because I have kids. No, it did let me raise my kids. It did let me stay on top of things. It was funny that I used to give a course, and you'd end up with a pregnant belly, and then you'd go have a child, and then you'd come back and give another course. And then I had 4 kids at a very short interval. And I was like, well, the students would come back and they would like, wait a minute, weren't you just pregnant before? And it's like, yeah, it's okay.
It can happen more than once.
Yeah. I have 4 kids and 5 grandkids, and the same husband putting up with me through all of this, and it's actually great.
Amazing.
So what you're saying is you were already practicing your software background with kids, because you already could use the parental term of if else, and then you're going to always be constantly looping through things where over and over you have to go loop and get the kids ready to school and out the door, and then yourself to work. So you sound like you were already kind of set up there.
Yeah, I think the grep command is usually the most used, right? Throughout the house. If they could grep mom for their shoes or their glasses or their whatever's. And my husband's a Unix guy, so but sometimes there would be a grep command there of him looking for his glasses. I'm like, well, okay, over there. So yeah, we
love it.
Computers sometimes in our house, and right. By us is whatever doesn't kill you give you XP, so level up.
Oh, that is intense. All I know is ping when you ping someone. So you guys are far beyond my vernacular. But prior to joining GM, where you are today, you worked, I think, like 14 years in software security company, ForcePoint. What, can I use the pun? What drove you into joining a car company of all things?
Well, like I said, 14 years in cybersecurity, doing more or less the same thing. It wasn't more or less the same thing. Just like at Cella, when I worked at Cella, right, I'd go off and have a baby and then come back later, and they say, well, if you go off and have a baby, then what's going to happen to somebody's going to take over? I'm like, yeah, they'll take over. I'll move on to the next thing. I love reading. I love new things, and it just worked. It was fantastic. And so it not that it was boring or bad at ForcePoint, but actually somebody that worked with me said, how about we go write software to talk to cars? And I'm like, no way. And he's like, way. And so I did. It was the first time I actually quit a job. I quit my job and it wasn't as easy as I thought it would be. It was actually really hard because I loved the people and I loved working them and everything was hunky-dory. It's not as if it was bad. It was wonderful. But this, and up until then, I'd always say, no, I'm not interested in any new jobs. I like my job. I know what I'm doing. This is great. And then the Kit Knight Rider?
Yeah.
That TV show when I was a kid,
Yeah.
every Friday. And so, okay, talking to cars. And so I did it. I went ahead and I quit my job, which was hard. And I went to work for a car company. And I think it's been so exciting. It really has been so exciting. It's amazing.
That is amazing.
Oh, I was going to say, because I was going to kind of follow up just on the aspect of, you got into the car world. And, as we were kind of getting just before the official kickoff, we were talking, you kind of mentioned you at the end of the day, you're a programmer at heart, right? That you love to be able to look at those things and be innovative. And oftentimes when you think of cars, you think of like mechanical and automotive specific engineering, where people are designing the coilover spring or the engine compressions and things like that. I'm just kind of curious, as you've been involved in the automotive industry now, how much has become computerized? How do you see the OEMs like GM and such competing with the likes of these big, huge tech firms everybody thinks about, like Apple or Google or Netflix? How are they looking to attract the top software talent these days?
Well, I think at the very beginning, when I started working for GM, there was quite a war of getting that software talent, and I think it wasn't anything that was specific to GM or an OEM or anything, right? It's everybody was competing, and I think the younger generation also has this tendency of working for somewhere for 2 years and then moving somewhere else. So it's like that's how you climb the ladder, by moving to a different company. I always climbed the ladder by just being good at what I do, I guess. And so we were actively looking for people to join and doing what everybody else does. I think today GM has definitely a status of being, at least in Israel, a software company, and a good one. And people are coming on their own. The jobs are being posted like everybody else, and I've seen some amazing talent join GM in the past year. People that are just amazing, and they chose us, right? We just posted it out there and they came. So I guess a car is at the end of the day something to take you from point A to point B, right? And GM is always concerned, and our first most concern is getting you from point A to point B and safely. And that's what a car company does. But today's cars are so much more than cars. They're actually a huge computer, and they can do so much to make our time in the car enjoyable and easy, and just make the complexity of our life so much more fun, right? So if you're driving the car and you can say, well, I have to stop off at my son's school and get him lunch. Could you please find a new route where I can stop and pick up a sandwich and then get to the school? If you could say, well, is there a parking lot nearby? I'm not going to make it. There's traffic. I need to join a conference call and then have the conference call on the screen of your car with the air conditioner on, or while you're drinking a coffee that you just got on the way through a drive-through. A mom with kids in the back of the car having some kind of infotainment, having play a song, have the kids say, play a song, right? And they play their song and they can choose their song and they can interact with the car while you're just trying to drive and get there peacefully. The kids interacting with the car is just keeping them busy, right? I don't know about you, but my granddaughter sits in the back of the car and she pushes the button for the window. It goes up, it goes down, it goes up, it goes down. It's like, can we leave the window alone?
Super high
for
tech,
the car.
window up,
Yeah.
down. That's
And then we got her into a car where you know
you still had to roll
the
up.
back seat to roll up.
You know, it's like a
What is
rotary
this?
phone. Give a kid a rotary
figured it
phone and
out.
see. Oh yeah, she figured it out.
Um,
Rotary
so-
phone or the window?
yeah, exactly. So the talent is coming, which is really nice. Another thing is that, like a phone used to be a phone, right? That rotary phone, you'd pick up the phone and it was a means to talk to somebody. I mean, now your phone is like everything. And if you lose your phone, you're lucky if you don't have a heart attack, especially the younger kids. Like, where's my phone?
I don't know. I'd like to lose my phone.
I don't know, Bo.
No, that's because you're over 25.
I've asked as a joke. I've asked an audience once, like, if you lost your phone and you lost your kids at a mall, which would you look for first? And it usually garners a chuckle, and people usually then say, "Oh no, I would want to find my phone first so I can call my kids." It's exactly what it is, but it's
Exactly,
a tough
right.
one to lose.
That could
It-
be-
heart
well,
heart
one of my
attack
kids
is
got-
definitely.
One of my kids got lost in the mall once during Hanukkah, and I stayed where I was, and the kid was brought by some nice lady who found him. But he came with this huge box of chocolates and toys inside, and he wouldn't share. And I just needed to get home, right? So I'm like, okay, we'll share when we get home. And then my eldest burst down in tears that she wants to get lost as well. And then go explain that getting lost and no, it doesn't go. We're going to share. Can we just get in the car and get home? Yeah.
That's definitely. So I can imagine, like, with all the amazing things that you guys are doing with the car and software, and basically software on wheels, as a lot of people are calling the SDV, there's still a lot of complexity. And I did read a recent McKinsey report that said software complexity is on track to nearly triple over the next 10 years. And that this is difficult for OEMs and suppliers who will have difficulty, kind of bridging the gap between complexity and productivity. And I was just wondering about, first, you can tell us about some of the amazing projects that you are working on, whatever you can tell us, that's not hush hush. And how are you and your teams looking at, again, trying to close this gap of complexity and seeing how fast things are amazingly being developed in the car world. I mean, soon, the batteries we have today, in a couple of, I don't know, months, years, it's going to be the next level battery, and the next thing that's going to come along. I mean, how do you catch up?
Let's see. So first of all, you want to build your domain correctly, right? Like in every piece of software, domain-driven design, and the pieces of software that you work with and their dependencies are really important. So the first thing you want to do is, like, if you have ADAS, active driving, active safety, that's a really big domain and a very complex domain. And it needs pictures from the camera, and it needs a whole bunch of stuff. But the domain itself is internal and it needs to be optimized. That's what they do, right? Now, you want the communication between one domain and another to also be standard, so that we don't have the complexity of, wait, you do REST? No, wait a minute, you have a queue, maybe some kind of other queue, and like, wait, how do I talk to you? And what happens if you fall down and I can't reach you? And wait a minute, is this a distributed system? Is there more than one computer in the car? Wait a minute, did the embedded world just go distributed? Shoot me now, right? I mean, And then you also have like I posted on the meatballs, right? If you split things up without enough communication, you have one team building the sauce, the other team building the meatballs, they both have to be deployed to a pan or to the car, and that car just does not, it has limited resources. This isn't the cloud, right? You can say, hey, let's get a bigger pot. Which is, I didn't do. I actually shook it and shoved it and put the lid on it. And it didn't overflow too much. And, you know, we do that as well. But you have to remember that the car is turning into a distributed system with many computers, and it's also limited resources. So how do we manage that? And obviously, I guess watching a movie is a little less important than actually maybe driving or mommy getting there. Or when somebody said that to me, I'm like, no, the most important thing is for those kids to watch that movie, and I'll drive the darn car, right? Hey, I'll do it. If they're quiet, I'm happy. On the other hand, right? You know, if I'm just driving and I want to find my tissue, and it's like, if I could really just drive yourself for 10 minutes before I sneeze all over the windshield and it's a disaster. So, yeah, there's trade-offs, and you have to decide what you want to do when, obviously. So one of the things we're trying to do is build what's called a uProtocol. It's open source. And the purpose of uProtocol, there's two things that are really important. The car today is signal oriented. There's a lot of microcontrollers pocketed all over the place. And we're kind of running out of room. And it's also very, very specific. Making changes on the CAN bus is not easy, and there's a size to it. And again, we're running out of room, right? You can't just add endless controllers everywhere. You have to be smart about it. And so some very, very smart people at GM, they actually built a new computer to the car, and they're going to communicate over Ethernet. And so we're going to go from a signal-oriented architecture to a service-oriented architecture, meaning going ahead and defining what the services are, right? A lot of domain-driven design, the inputs and the output, right? And even make it event-driven. So a car is just a big state machine. It's driving, it's stopping, and you can make this event-driven. You can send a message, which is a command, to say, roll down the window. And that message has a structure, just like any other kind of service-oriented architecture. And you send that structure. But wait a minute, you can't talk directly to the car. You could do, say, REST. You could do maybe Kafka. You could do whatever technology that is at your fingers. So how's that going to get to the car? And then we have designed something called uPlatform. And what uPlatform does is it's a way to communicate with two pieces of software with strong contracts, but they can't communicate directly. They need to go through what's called a uPlatform to get commands, which is just a message with an intent to change something in the car. Roll down the window. The car could go, I'm driving way too fast. That window is not going down now, right? Or, okay, opening it all the way is probably not a bad idea. It is a bad idea because I'm parked and I'm in a shady place, right? So I need geolocation service and to know, oh, this is a shady place because somebody said that, you know, my car was stolen. But I want to open the window because I'm coming out of the shop and I want it to be cooler, and I don't want to turn on the air conditioner because my battery's a little low. There's so much logic that if you think about it, you could build so many cool applications in a very agile way if those services are exposed in a strong contract. This is how you open the window. This is how you send that command. And when the window does go down, you get an event. An event means something happened. It was wrong. It was good. It happened. That's life. And then you could subscribe to those events. And then the theft detection can go, whoa, 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 what's the window doing down? And say, okay, you're going back up, right? Turn on the air conditioner. Wait, you have a charging station, which is just around the corner. You could afford to cool your car. Think about it. If we expose services with a strong contract, and we have a way for any developer to go ahead and write software, then we're creating a really agile environment for writing software to the car. Remember, GM will build good cars, will build batteries, will give you that like phone, that iPhone, will give you that structure to go ahead and build amazing things for the car. We don't have to build it all the time. We'll just give you a way to build it. And then you can have an app store and then like Google Android thing, and you could take but $2 for it. But the idea is, yeah, take $100, go put that on Azure, right? Go give it to your customers. Are they willing to pay $1 for it? Are they willing to pay 50 cents? Okay, fine. Are you covering? Can you deploy this? Do you have customers? Awesome. If not, talk to them. Maybe you can make it better. And if not, dump it in the trash. So instead of taking years to develop applications for the cars, we're shortening the time. Now, again, you have to look at different domains, right? So active safety, active driving is one big complex domain, and it's more or less a closed domain, right? It's not, it'll probably have its internal protocols, it'll have shared memory, it'll be very, very efficient because there's only so much room for those meatballs in the pot. But in order to create innovation, there are plenty of services in the car, lights and doors and air conditioners and tire pressure, and you name it. There are so many things in the car that can be easily exposed to services. If you have a little bit of latency, you push the button, you say, open the window, please. It'll take a half a second, 1 Mississippi, 2 Mississippi, 3 Mississippi, window goes down. You could live with that, right? And then you get an event, we have lowered your window. Your car will be nice and cool by the time you get out of the pharmacy. It's amazing. Think about it. All that integration, all that innovation, you can really go nuts with so many things. And it also enables vehicle to vehicle communication, especially if we're talking about location. So, okay, if we all play and speak the same language, then innovation on communication goes boom as well, right? So if we all know how to lower the window in a Mercedes and lower the window in a GM car, suddenly we could write the application once and sell it to anybody who wants it. So if I have a Mercedes, right, and my husband has a GM car, well, he's got a Cadillac, right? Let's get fancy here. We could have the same application. It doesn't matter, you know, where you are in your house. You could use your Google Assistant or your Dot or whatever to connect to the car and then tell it to do whatever you want. Doesn't make a difference where it is. Actually, funny story. They were talking about an application for finding your car. And I sat there scratching my head, looking out the window going, yeah, right over there. Apparently in California, you could have a garage with 5 cars. And if you're not the one who drove the car, you know, you have to go find it in the garage. I'm like, oh, never thought of that.
Isn't that just the
Okay,
clicker?
fine.
You just go around just clicking
Yeah,
the thing
you
if the lights go
could,
on?
you could. Yeah.
That's
But-
how
but
I
That's the
think about
old
how-
school, tried and true.
Yeah. You know
But
that,
think
you know
about
that
it,
that commercial with a guy who was plowing out his car from the snow, and he was plowing it out, and then he does the clicker and it's the car behind him that he didn't plow out. He
Right.
plowed out the wrong car.
Right.
It comes to mind.
But
Yeah.
you know, if you have a 5-car garage, a 5-car garage, and
Sure.
you know, you kind of say, okay, bring it around, right? So it could take it out of the parking space, out of the garage, and drive it to the front, especially if it's raining or whatever, and then you just get into the car. There's so many things you could, it's your house. It can be mapped super easy. You just drive it once or twice and you tell it, remember the route. It's nothing. Think about the innovation, think about how it could really make your life so much better, because it's not just a car, it's a big computer.
That's super cool. And your involvement with the Eclipse Foundation, how is that helpful for the I guess the creation of the uProtocol?
Many things that I've been doing is the developer side, right? So we said that I'm an architect. Thank you very much, Mrs. Architect. But I call myself a coding architect. I'm very much in line with the developers. I am not an ivory tower architect. I don't sit there writing specifications and not being connected. And actually, that's part of my job. A lot of the specifications are written by very smart people. And I code them. I take a look and see if this works and how it will look for a developer and how we could make it even better. Because at the end of the day, the goal is to enable innovation, enable working with the car. I mean, we're taking trade-offs here, but what we want to gain from it is the ability to innovate fast, to be truly agile, and to truly work write automotive applications. And so I have written some of the SDKs. I have done a lot of data modeling to make it easy, right? You know, I don't know if you've read some of these specifications. Sometimes it can be hard. And so I take them and I just do a lot of data modeling. I build objects, static factory methods. You could have the same mental model of working with something in Java and of working with something in C++ because it's the same mental model. It could be written a little differently, but the mental model is the same. And so now go ahead and write it in Rust, in C++, in Java. If we give developers an SDK and we give them, you know, this is what you have to do, it's just a little bit of boilerplate. If we create code to create the boilerplate for them, or if somebody comes along, it's open source. Tooling, you want to write tooling, you want to make it easier, that's fine. Nobody said distributed systems are easy. Nobody said cars are easy, right? You want tooling? Yay, we're out there. Come join the community, make it easier for developers to write code and to write amazing applications for the automotive software world, right? So maybe we don't need to start getting all of our internal software talent. Maybe we have amazing people and we're creating enablers for other people to go ahead and write software. Now, obviously, it has to be secure, and obviously, it has to be safe, and obviously, it's totally not as simple as I'm making it. But maybe we can, right? Maybe we can abstract the complexity out of writing software for car by using standards, right?
Yeah, and you mentioned, you know, first of all, your passion's oozing over this, and also some amazing people. And I've met a couple of amazing people like yourself at GM, and really, it's like, it almost feels like they're trying to do things faster. I'm always trying to find the best tools and the best way to kind of really get what they're so passionate about faster to the market, into the hands of consumers, so they can really fully enjoy this experience. So it's a truly a pleasure to see the innovation and the overall, I would say, constant check of productivity. Make sure the developers are, you know, with all the amazing things that they're doing, are, you know, have what they need to do their job and are enjoying the work as they go along. And I guess standards, like you said, is a big part of that.
Yeah, look, we still have days where, you know, you have a big demo and the car's got to drive, and like every software company, we're still there. You know, it's not a walk in the park, but the idea is to make it better. And again, the idea is to, like they did with the phone, to just be an enabler to make the car a better place to be in. You know, it's sometimes they say, well, we have a zero congestion, zero emission, right? I'm like, well, okay, we're making it so much fun to be in the car. That's not helping zero congestion, right? But yeah, they definitely, if you think about robo taxis like Cruise or self-driving cars, one of the things that I think is so cool, if whatever makes a train so efficient is that there are no merges, right? The train just drives. Sometimes it has to wait for a track change, but it just drives. But think about it, if we could make a train of cars, you're sitting in your own car, but it can join the train. You don't have to merge. It'll be a smart merge, right? Especially like me, I sit there and nobody's honking behind me because nobody's letting me in, right? Or the guy that just cuts you off and you have a heart attack because you just got cut off and hit the brake and the other guy smashed into you. And it's like all the things we know about on the road. And if you can make that kind of train on the road and have cars talk to each other and use the edge, and there's so many things you can do. It's really amazing when you think about it. I mean, you know, I was so excited about Kit the talking car, and then when I moved into the architecture group and I see all the additional things that a car has, it is just mind blowing. And we'll get there. GM is not going to be probably the first and the fastest because of the safety regulations and making sure that this will work and it will work well and safe. You know, we're not going to experiment on you, but we will get there. And when we will, it will be so awesome.
Sweet. That was, it was interesting to hear you break down all the complexity and all the different things you have to say, like what you're looking at on, just even to the point where you were saying like, hey, do I put the windows down to cool the car off? But wait, the anti-theft says, well, maybe this isn't the right time to do it because it's 2 a.m. in the morning or something along those lines.
And the shady, I love the shady word. Shady could be shady from the tree or shady area. That was great.
Shady on both sides.
Yeah.
So one of the things that we're hearing about a lot in the news these days is AI, right? And we're seeing all sorts of opinions now, from it's the greatest thing ever, so I can write my essays and my homework, to Skynet has risen and the planet's doomed. You know, but in the middle of the spectrum, again, are the software architects, the developers who are looking how to understand and integrate AI in a software-defined vehicle. And so when we start thinking about that with the complexity, I'm kind of thinking, well, how do you think it's going to change the playing field in the automotive industry? Is it going to be used to review things for safety recalls, right? My last 2 things that my car was recalled for was strictly software programming. I'm curious as to your thoughts on things like ChatGPT for, you know, for voice assistance or other areas of the car that the driver and the passengers may interact, right? You talked about watching the movie in the back, keeping my kids going. And then of course I'm sitting here thinking, okay, maybe I'm not on the Skynet has risen, but how are you going to prevent things like AI road rage, right? If it becomes self-aware, right, you're driving and it realizes, hey, that person in the left lane is not getting over and you're going slow and you start tailgating. I'm just kind of curious as to your thoughts on how do you see AI coming in with all of the complexity of an SDV?
AI road rage. You heard it first here, folks.
Well, I guess it's all about containment, right? It's all about models. We've been using models forever, right? It's not new that models were out there. It's not new that Google had a ton of right. They drive around and take pictures of road signs, and then you could take a picture and say, "Is this a road sign?" Cameras and viewing and all these things have always been around. I think the really big things are the language models of exactly that. I don't think that you know, ChatGPT or even drawing images are going to go into safety just yet. Like you said, that we're not letting Skynet in there. It's not safe enough. If it gets to be safe enough and you can convince us, hunky dory. Now, I do see talking to cars, right? And so what you need to do is you need to contain the model. It's not going to go out to the internet to look for a question of how do I open the sunroof? Well, what's it's going to do? First thing is it's going to go to the calibrations. It's going to say, does this car have a sunroof? And we're going to go, yeah, you don't have a sunroof, which is something I always, you know, hello car, open the sunroof, and the car going, no, you don't have a sunroof, but you know what? There's a great deal at the Chevy with the sunroof.
That's what I say. It's like, go 2 miles, turn left, and there's somebody will hook you up with a sunroof.
Exactly.
In the
now,
shady
if there
area.
is a sunroof,
In the shady area.
No.
Exactly.
Now, obviously, somebody said that because they do have a sunroof, right? So, you could go ahead and open the sunroof, but think about the owner's manual. Think about wanting to ask the car. I mean, again, the joke about that is that in some of the Cadillacs, to open the glove box, there was a button, right? It wasn't just to put your hand and pull a lever. It was a button that opened the glove box. And then it would be like, you know, hey, mom, how do I open the glove box? And it's like, I don't know. Look at the owner's manual, but it's in the glove box. So, right. Go look in dad's car. But the idea is that if you want to get something for the owner's manual, you know, you got to open it, you got to read through it. And let's be honest, that thing does nothing but take up space. And most of the owner's manuals today are digital. So why not use ChatGPT to understand language? It's like, hey, Gar, how do I pair my phone? Hey, car, do you have Super Cruise? Like, how does this thing work? Hey, car, my kids really want to watch a movie. How do I make this work? So actually, and a conversation, right? Having to be able to say, how do I open the sunroof? How do I close it? And understanding, right? Context, all those things are really cool in ChatGPT. But we really don't want it giving answers that aren't really specific to your car. Meaning, if you do not have a sunroof, then it's like, you don't have a sunroof. And if you do, then, to open the sunroof, push the button, or you could also use a voice command to open the sunroof. Say, hey, car, open sunroof. For example, if we wanted it to be super specific. And if you're asking things out of the owner's manual, again, it has to be super specific to your car. So I do see those models reaching the car because I think it is super useful. And the voice team is actually working on those things. Sometimes you can use ChatGPT to check things, but I can definitely see it being used through the voice technologies to talk to the car. It probably won't go out to the internet. It'll probably be on a very constrained model. And we're definitely not letting Skynet into any of it. It's a lot like the things we've done today, right?
I was gonna say, because I could understand, like, younger me loved to drive fast. Older me still likes to drive fast, but if you can do the whole using ChatGPT, how can I bypass the speed governor? Yeah, we got to put those locks in, or every teenager is going to be driving entirely too fast. But
true, but I don't think those things are in the owner's manual, so you won't get them, right? You'd have to search the internet for that, and then somebody would have to publish it, and then again, who's liable if you did? So there's a lot of liability there. The idea is that everything coming from the owner manual obviously is legal and has to be checked, and safety.
You just brought up a really interesting point, Tamara, and I know this wasn't, this is kind of like a little secondary question, but you're putting all those things together, and you just brought up an excellent point about liability. Do you have to work cross teams, like with the legal department or with another, I don't know, the marketing group or something, as far as like when we are going to say and do this human interactions? I'm just curious, when you guys say, hey, here's a protocol, we're building it, does it have to go through like another review of somebody else to say, like, wait, hold on a second, if we do that, we open ourselves up to a liability question, or we need to make sure we lock this off, so you don't have some kid saying, hey, ChatGPT, how do I?
Obviously, anything we do, a lot of the time there's compliance and there's legal, even a dev portal that we're working on to help people develop uProtocol. There's compliance and there's legal and there's internal GM and external GM to the dev portal. And very funny story is that obviously I needed an ops guy. And so that's a bit sexist, but I did say, went to my boss and I said, listen, I need an ops guy. And he said, okay, look, there's this Michael guy that I worked with. And so he sent me an email, and I opened a chat and I talked to this Michael guy. And, we were talking about contracts and service-oriented architecture. But basically I talked a lot about contracts and a little bit of Jenkins in there. And at some stage, after 10 minutes in the conversation, because I actually looked at the time we'd been talking, he said, I'm a lawyer. And I'm like, okay, yeah, I think we have a mistake. And it was a lot of fun. We chatted a little bit afterwards, and it was great to know, a lawyer said, listen, if you have issues with this and that and the other, I'm your man. But I don't think I can do your ops things, right? I don't think he even knew how to say do your ops things. And then again, I went back to my boss. I'm like, Christopher's a lawyer. And then he goes, oh, wrong, Christopher. I'm like, really? And so got my ops guy, but yeah, so things happen.
A lawyer who knows Jenkins, that's definitely something I would put up.
No, but there are a lot of them. And it's very, very important. And liability is very important. And security is very important. And then, of course, you get to your trade-offs. It's like, if it's going to take 5 minutes to open the window, that's not going to work. Right. So how do we work with that? How do we work with latency? Right. The car is very latency sensitive. I mean, we're all latency sensitive, let's be honest. We're willing to put up with so much, but everybody wants it now. And then how do you do that in a safe way How do you do that in a good way? How do you do that when pieces are failing, like in any good distributed system? You know,
Excellent. So I wanted to, Tamara, I wanted to ask you, because this is a topic that's coming up in the dev space, and as a senior architect, I wanted to know your opinion on the monoliths versus microservices debate. We went from it was the best thing to going back to it's not exactly what we thought it was, and going back and forth. I'm curious what you have to say about it.
well, like a good architect, I will say it depends. And at the end of the day, like every architect should, it's your trade-offs. So if you take your domain, you model it, I love domain-driven design. I think it's an amazing tool. It lets you do task-driven behavior, development, anything to do with that. Domain-driven design really, really gives you the tools. And so, like they say, you need to understand your contracts. And if you have strong contracts, if you set them up as microservices, by definition, there is latency. By definition, there's network. By definition, more things can go wrong. Now, if it is beneficial and having decoupling between those two services is beneficial, then you're willing to pay the price of the latency in the network and the things going wrong. But if you realize that latency or that networking or any other trade-off that you make with microservices isn't cutting it, you just take that thing and you put it back together because you need to answer requirements. And you see that a lot in my world, right? You see that a lot in the automotive world. So everybody comes along, Conway's Law, they want to build a service, right? Services are cool, but just a minute, you're pulling that out. Even in the car, there is networking, there is latency, there can be, but there is theoretically a shared nothing, right? If it's together, we share memory space, we share address space, we can do zero copy, we can be very, very efficient. Remember, there's only so many CPUs in the car, there's only so much memory. We have to be very efficient. And data models, working with data models, we all know it takes time, it takes resources, and our CPUs are going to go ahead and do a whole bunch of stuff. And so it depends. You have to take a look at your domain and not be afraid to, like they say, bite the bullet. If you need to make a change, if you made an architectural mistake, bite that bullet. Either rip it apart, put it back together, whatever your requirements demand to build what you need. It could be where you're deployed. You could decide that you're deployed in the cloud. You could decide you're deployed in the car. There are different trade-offs entirely, right? One's an embedded system. One is a system where latency is okay or not. So you need to take a look at your trade-offs, take a look at what you're doing, and not be afraid to be agile, to change, and to test. Test early, go into those cars, get your coffee, put it on those test cars, and take a look. It might be the greatest thing since Pocket and Pita, and it might go, oh gosh, this is never going to work.
I love your food analogies, Tamara.
I would say she's blending
really
in the food analogies really well here.
And we're past lunch, or at least for us in Israel. So I don't know about that, but you had a meatball analogy. I like that one. Maybe you can remind us about that one.
You have kids, when you have kids asking these questions. Your kids grow up and they start being on LinkedIn and Facebook. At the very beginning, you're on Facebook, so you're embarrassing your kids, but wait a minute, you're on LinkedIn. That's my mom. All right. So it kind of changes, depends what social media you're on. And then you get, kids growing up and asking technical questions. It's like, what's the deal with this? What's the deal with that? And then as I look at my meatballs, like, okay, meatball analogy, right?
Awesome. Actually, a recipe book to explain technology. How we should do that. How cool would that be?
Okay.
A recipe book for mansplaining technology to people.
Well, actually, it's the men usually that understand technology, right? And it all depends. So like my son's in IT, and when my mouse doesn't work, it's like, wait, just a minute, Mom, put a new battery in it. And it's like, well, it's not opening. It's like, hold on, I'll be there this afternoon. I'll replace the battery. It's so embarrassing, but let's be honest, right? It's like, how can you build so many complex systems, but you can't reverse park? I'm like, it's a different skill set.
It's going to be automated soon. It doesn't matter.
Yes, exactly.
That's right. They do. There's the most amazing trailering ad for GM, where this guy is backing into, he's got a horse in a trailer, and he's backing into the spot because the horse has got to go into the crowd. Right? He can't just let it out anywhere, theoretically. And the horses are waiting for him to come, and they're dying. They're laughing, right? You used to get this Mr. Ed kind of scene, and the horses are dying and they're laughing. And then the next time he comes with a GM car and with the parking assist for trailing, and he just pushes the button and it smoothly parks, and he kind of smiles at the horses, and they're kind of like, let's go find our entertainment elsewhere today.
That's cute. When are we getting crab crawling parking? You know that, where basically the wheels turns and they just go, they do that also.
The Hummer has it.
The
Hummer has it.
Yeah.
Ooh.
Yeah. Google
Get
crab
myself
walk
a
on the Hummer. It is pretty awesome.
Yeah.
But that car's
Wow.
huge. It is so big. I mean, most of the GM cars are really, really big. It's crazy.
So you have a car that can't really park anywhere because it's so big, but it has the best parking technology out there.
Well, it can park in the States,
Yeah.
I guess. I wouldn't park it in Tel Aviv, but yeah, in the States.
I was going to say, the States, I'm not worried about it unless maybe you're in the far northeast or something. But yeah, Tel Aviv might be a little bit harder. I don't know. I'm just still hoping that no matter what y'all do with software, please just make sure that I have the twist knob for my volume. I know so many companies have been going to like the touch screen. You're like, I can't find it. Where's the ChatGPT? Please turn down by 5.
Yep.
That's that whole monolith versus microservices debate there.
Yeah. Well, you could always rip it out and put in an analog one, right? Like anything. But there are a lot of analog things in the car, right? If you think about the trucks had so many buttons, it was crazy, as is people trying to figure out what all the buttons were for. So actually putting a lot of them into the infotainment screen was the first way of handling, like I said, all those microcontrollers everywhere. It doesn't scale. At some stage, it doesn't scale, and then there's a fight. I need a button. Where are we going to put it? And so at the end of the day, it's like, okay, everybody's going on to infotainment except for these guys, which are the most important. Everybody else, you're on infotainment. Figure
everybody
it out.
else out of the pool.
Totally.
It reminds me. I just watched the BlackBerry movie the other day. By the way, it was so nostalgic. I was definitely a crackberry back in the day, but it was exactly that I guess say tipping point of that part of the movie where they're all sitting there watching the iPhone release, and they're like, everything's on a screen, and then you see the execs trying to like now figure out what is it they're gonna do, and they're saying, but people like to click. That's our thing. We're the clicky people. Like people like the click feeling to it, and it reminds me of this. Like people like there's the screen, right? You've got so much you can put on the screen, but then people just want to like put the volume button, feel that, or the air conditioning thing like on a separate system, so you don't have to start fussing with it. So there's a lot there. Yeah, customization.
So now we're going into, there are a lot of UX people, right? UX, UI, customization, everybody wanting their own thing. A lot of the thing about AI today is in customization, so that we don't get the same screen. It's the same thing, right? We don't get the same answer. We don't get the same screen. Everybody has a personalized feeling about everything. So when it comes to screens, that definitely can be there. AI can give you fun screens. AI can let you talk to the car. AI can give you that experience. It won't drive the car. That's still doing it a more, I don't know if you'd call it traditional way, but a different way, right? Yeah. But I think I do see AI coming into the cars slowly, but more to interact with people. It's a human thing. That's what it's all about. Artificial intelligence. A car is not intelligent. A car needs to drive in a good, intelligent way, but it needs to drive. But wait a minute, The systems in the car could be like a person, like a personal assistant talking to you, interacting with you. That's what it's all about.
Fun. All right, now we're gonna enter a little one of our fun questions that we like to talk to folks about is affectionately we call it DevOps, right? Where we just basically talk about something that, you know, as you're learning, we're humans, we all do things. Sometimes we're like, wait, what did I just do? Or sometimes we do something and it blows up, you know, miraculously in our face. It's just kind of more like, tell us something that's kind of humorous about where you were doing something with tech. It doesn't necessarily have to be strictly about code, but from something that occurred that you basically learned from that, right? That it helped you grow or realize and perfect your craft or be able to mentor and coach others. Like, wait a minute, whatever you do not type rm dash recursive force
Right.
on these systems, right? Just kind of curious if you had some little funny anecdotes along those lines.
Who said they were a COBOL developer? Somebody said they wrote COBOL. Do you remember the COBOL compiler was RM? That was the name of the compiler, or RMI or something. And then if you made a mistake on Linux and put a space there, then it would delete your files or something. I think the first thing I did was fix that. That was in high school a long time ago. Who remembers? But I just remember that. But I think, first of all, the worst experience is the best story if you know how to tell it. But it has to be your story, right? So if you're going to go ahead and talk about DevOps that aren't your stories, that's already another shady area. And like I said, I really try and stay away from the ops side of things. But I mean, I've definitely been programming for such a long time that I can relate to the things in the books. So there's an amazing books by The Clean Architecture by Uncle Bob. And, you know, I think the whole book is him talking about his failures and what he wanted to do and it didn't work, right? He didn't want a database and somebody made him say, well, everybody's doing databases, you have to have a database, right? He's also an embedded guy. And so, you know, I've definitely had the first cloud deployments where, you know, you put a consistent hash ring, meaning if one falls, somebody else can pick up the load. But wait a minute, he fell over because he couldn't handle the load and everybody else is just managing to handle the load. And now you give somebody else's load plus the load and basically your servers go boom, 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 one after the other, and they all restart. And then if you're lucky, the database survived. And if you're unlucky, then it fell down. And then when everybody's coming back up, the database is kind of managing more or less, and then it barfs. And you're sitting there blinking saying, well, I think my observability of this system isn't very good. And this consistent hash ring is not a good idea. You know, this is not how we scale systems. I am definitely a huge fan of Jonas Bonner and the Reactive Manifesto, and you know, developing software systems that scale not by putting your state in a database and you know, having those DAOs with all the logic. I love in-memory state, which is fast and clean and clear and basically lets your database do what it does best, and that's just persist stuff. And have the logic in memory and the ability to scale and location transparency. Like a total fan. I think it's the most wonderful thing. And it actually did solve a lot of the things that I saw. Distributed systems are hard. And like I said, the Akan Action book that I've been reading, it's just, it's a second edition. I've read the first one. This is the second edition that I'm rereading. Because things did change and I just love to read. Problem.
There's nothing wrong with that. Do you, just curiosity, do you mainly read a lot of technical stuff, or are you pretty broad based as far as eclectic as far as what you like to read? I mean, I'll admit the last book I just read, I finished up just a few days ago, was an Agatha Christie book on the mysterious what was it, the mysterious affairs at Styles. So I mean, it's just a mystery book. I just, what kind of catches your attention?
Well, I'm in tech because I love it. I'm always thinking about a way to solve a problem because that's what I do. When I was younger, I did a lot of UI because I had 4 kids and I needed success. Like I said, set yourself up for success. So if all I managed to do at that day at work after, I don't know, meetings and somebody being sick and getting barfed on at night and just being so tired that I don't know what my name is, and lucky that my car knows the way to work, because if I had to drive it, it would be a disaster. I put that button on the screen in the right place in a reactive way. It doesn't do anything just yet. If you click it, it says this is under construction, but I put that button there. And I always tell my kids, put your hand up in the air, put it on your shoulder, and pat yourself on the back, because if you don't do it, nobody's going to do it for you. And so I love reading technical books. I definitely love reading fantasy, hardcore science fiction like Asimov. He's amazing. Basically, I'll read almost anything you put in front of me, unless it's a, boring romance, which is, I get bored with that. You go watch
All right, no technical romance, no ones liking
no
zeros,
technical
no
romance, but yeah. But if we're talking about DevOps, I love reading. There's a great book called Release It. There's a second edition. I have a second edition. And he speaks about exactly that, about how software was released in the past, and how, observability tools, about all the times where at 3 o'clock in the morning, he's called to a war room to go figure out what went wrong, and all the things that you should do so that you don't end up at 3 o'clock in the morning in a war room trying to figure out what went wrong. And those kind of books are usually really fun to read, because again, the worst experience is the best story if you know how to tell it. And obviously they're writing a book, and obviously they know how to tell it. So it's fun. I do read everything, but I really enjoy reading technical books. And when you Google something, it only gives you just like a really narrow perspective into what you asked. And if you don't know how to ask it correctly, then again, you'll get a straight answer. But books, they also talk about the surrounding scenarios. They give you a broader way of thinking. And as an architect, we should be thinking, we should be questioning, we should be trying to find better solutions. And books help me do that. All kinds of books, even, reading the Witcher series, which it was actually quite boring. And I read it just because of the TV show. I never played the video game, missed out on that part of my life. Like I played Donkey Kong. That's how old I am. But yeah.
Hey, there's nothing wrong with I got a lot of white in this beard these days. I was playing Pitfall and Donkey Kong and even Pong back in the day. So yeah, we're all friendly here.
Vario,
on
the real
on
Vario,
those
and
games.
yeah, and what was it that I played with the kids? With the mushrooms. There was some game that at the time we played with the kids. I can't remember, but they had great graphics.
Well, I can tell you it wasn't Leisure Suit Larry.
No.
Oh, you remember that game?
I remember that. I mean, honestly, my most favorite game was a game called Tempest, which is probably at best 8 bits. But you go down and you'd feed the quarter into the arcades, and you just had a little dial and a button. There wasn't anything else fancy, but you had like a little spider character, and the different webs would appear, and little 8-bit graphics would come off the webs, and you just had to circle around and shoot it. And that one got most of my money. But I think when you're talking mushrooms, there's are you talking Story. Like Super Mario Brothers or something when you had the little mushroom character?
Maple Story.
I can't say I know that one. I'm gonna have to look that up.
Amazing graphics. Yeah, look it up. It's actually still active, and it's a lot of fun, and it's interactive. Like I could have 3 kids. Actually, they'd go to the neighbors. We only had 1 computer, but they'd be at the neighbors and they'd be yelling over the fence, "What are you doing? Enter the quest!" Oh dear.
What's the quest? Tamara, we get, when we're talking with folks, we hear some really fun stories about how just day-to-day coding and day-to-day building occurs. We've had some folks that say like they built on a boat, for deep sea mining and oil, and they've had other people who have done things coding in a van outside a sports venue to get something completed just in time. Spoke with an individual the other day who had mentioned that, hey, we had to run some of our stuff in a borrowed music room. Just a little funny things like that, where, you know, at the end of the day, we're all about trying to get it done, right? And so just kind of curious, do you have any fun little technical storylines around however you were building, or hey, I had kids in my lap but I was coding with my other hand? Just anything about the way life happens.
Totally. Well, the first one was when they were younger. Again, not an ops guy, but definitely coding and thinking, and definitely found myself rocking the supermarket cart because I was thinking about a problem. There was no child in there, but I was rocking the supermarket cart. Anyway, I've definitely coded on the floor, with kids around me, with people stealing my mouse, and hey, I'm black screen Linux hardcore because everybody kept either taking my mouse or pulling the cords or whatever, just type it straight off. During my training days, when I was training, there was homework that you had to do, right? Programming is all about sweating it out through the keyboard. And they never gave my phone at home because, again, there was no point with 4 kids. I think I had 3 at the time, and somebody called and my daughter answered the phone. I think she must have been 5 or 6. And she said, well, listen, my mom's changing a diaper, nappy. And he said, I'll wait. And then she said, well, when she's finished with that, my brother is waiting for a bottle. And then he said, well, that's okay, I'll wait. And then she said, well, you should just know that after the bottle, I need something as well. And he said, that's okay, I'll wait. And then this amazing child said, well, you should just know that these babies poop all the time. And by the time she's finished with me, she's going to be changing another diaper. And then he realized that there is no way this child is going to give up the phone because she has 2 little brothers and she knows exactly what it means for somebody else to get in line and wait. And it was really funny that the next day in class, he came with a little round token that used to be used for phones way, way, way back in the day. And he said, I looked this up and I went to my parents' house to find one. And back in the day, when you wanted a girl to call you, you would give her this token. She'd put it in the payphone and she could call you. And he said, this is for your daughter when she grows up, who I'm really proud of. She's an electrical engineer, builds buildings. And an amazing child, but even back in the day, you could see she was amazing. So yeah, coding with 4 kids or coding with kids is definitely a challenge, but you just have to laugh your way through every single bit of it. Otherwise, like anything, you can't get through life. Trying to get to a class, not smelling of somebody spitting up on you, your skirt being clean and not having chocolate on the edges. And with all that, not having dog hair on it. And I've definitely coded at all kinds of spaces. I've definitely had conference calls from all kinds of weird spaces on the phone. But no build stories, because like I said, that's my husband. He's the one who does the 24/7 builds. He's the build guy, the CI/CD and the build guy. And again, if something does, I'm like, it's what was that Linux thing? And then how like they come and they write this really big long command on the console, and then it just pops up. Your PID is 75. Yes, right.
Yes.
Yeah. So he's one of those. Definitely a high-techy house.
Excellent, Tamara. So thank you so much. This has been fun and informative. And I just wanted to, we were talking about reading, and you mentioned, is it ACA or AKA?
AKA.
Yeah. In Action is a book you're reading now and loving it. I thought maybe we can end off if you can give us a fun recommended reading list for the summer. I just imagine you like on a hammock with like a really thick O'Reilly book, like just kind of reading through that.
Actually, I'm a Manning fan.
Oh, Manning, you're a Manning fan? Okay.
Yeah. One of the nice things about Manning, if we're already going into promotions, and they give you, when you buy the book, they give you a live book and audio, like a lot of things you get almost for free for buying a book, which is really nice because I'm definitely a paper girl and I like to hold it, and I definitely cross-reference with my books, but it's also nice to search so you don't have to pay extra. So those are really nice. Okay, so I think that functional programming is amazing. I think that if we write more functional programs, our programs will be better, easier, we'll have less bugs, and they'll definitely be easier to test. But most of us are imperative programmers. That's the way our mind works. And it's sometimes hard to make the switch. So there are a couple of books. There's for the Java programmers, there's Functional Programming in Java, which is blue, and it looks like the Scala book. Functional Programming is Scala, but the Scala one's red and this one's blue, and I definitely recommend that one. There's also another one about functional programming. It's grokking functional programming, which is amazing. It gives a lot of examples in Scala, but it explains why exceptions are a bad thing, but for real, right? Because you're like, what's wrong with exceptions? It's a contract. Why are exceptions bad? Why do I need to have a computational context? It's a big deal about throwing an exception, right? Observability, like in my defense, I was left unobserved, right? That's what my kids, no, I was, unsupervised. In my defense, I was left unsupervised. Says every piece of software that chucked an exception at you ever. Because if it was being supervised, it wouldn't have chucked an exception. Somebody would have said, oh, you have a problem, no worries. Let me take it up the chain and handle that for you, right? I don't go barfing exceptions when I have a problem. I go to my manager. I was like, handle this, right? I can't handle it. You handle it. That's your job.
I love it. I'm going to start using that chucking exceptions to my manager. I'm like, sorry, I'm chucking an exception. I'm not doing
That's
that.
Right. Exactly. It was like, oh, excuse me, that's not acceptable, right? Why should it be acceptable in software? So those are about functional programming. I love Akka. They broke my heart when they changed their licensing, and now you have to pay for it. But it is well worth every cent you will ever pay, because it's an amazing way to build domains, at least in distributed systems, that are scalable and resilient and reliable. It's not easy. Buy the book. There are a bunch of books, not kind of bunch of books in distributed programming. And the next thing is Rust. I'm not a DevOps girl, not an embedded girl. I work in the cloud. I worked in distributed systems. I've definitely written my share of monoliths, right? I've been around for a while. Which is not always a bad thing, like we said. But Rust apparently is a C++ on steroids, and it apparently is very functional. And if you've ever done any Scala, then Rust is a way to do functional C++, which again, from a bit of Googling, also is getting functional. So Rust in Action and another Rust book is on my reading list. Like you said, for the summer, when I'm on that plane, or when somebody's not calling mommy or Safta, which doesn't happen that much, but when it does, then yeah, that's my reading list for the summer.
Fabulous. All right. Thank you so much for listening and for watching. Appreciate your time, Tamara and Bo. See you on the next one.
Incredibuilt. Development never stops.